Let me take another example, how to find out microstates. We can find out microstates in any configuration. I'm going to take one or two examples more. For example, carbon, its electronic configuration is 1s2, 2s2 and 2p2. Therefore, maximum number of electrons which p orbitals can accommodate is 6, and the configuration which we have is p2. Therefore, n factorial divided by r factorial, which is 2, multiplied by n minus r, 6 minus 2. And if we do the factorial thing, then it will be 6 factorial divided by 2 factorial multiplied by 4 factorial. And this is how we can do this factorial thing. 6 multiplied by 5 multiplied by 4 multiplied till 1, and this one 2 multiplied by 1, and then 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1, and this is equal to 15. We can take now another example from transition metal, and that is D2 case. I think you remember D2 case is titanium 2. So we can find out maximum number which a d orbital can accommodate is 10. It's a d orbital. Then there are 2 electrons in the d orbital. Therefore, 10 factorial divided by 2 factorial multiplied by 10 minus 2. And this whole thing will come down to 10 factorial divided by 2 factorial divided by 8 factorial. And if you do this factorial thing from 10 down to 1 divided by 2 multiplied by 1 and then 8 down to 1, it comes to 45. So this is how we can calculate the microstates present in titanium 2. Below is also I have done the same thing, but I have put some colors in it, as you can see in your slides. Okay, so now the next thing which I'm going to do is give you a very quick method for determining the microstates in any configuration. I will explain it with the help of an example, and let me take example of a D3 case. Find out, first of all, the step 1 is the maximum number of electrons in the orbital, that is equal to n. Now it is a d orbital, so value of n is equal to 10. Step 2 is, what is the actual number of electrons in the orbital of the given configuration, that is R. So value of R in this case is 3 because it's a D3 case. Next, the total number of microstates which we can find out by this quick method is simple. Here is n, which is 10. Okay. and let us descend it down to 3 numbers, that is 10, 9 and 8. Divided by R stands starting with 1, ascend it up to 3. So this is how we do. Total number of microstates will be 10 divided by 1. We keep on descending the numerator and we keep on ascending the denominator. Okay, so 10, 9 and 8. That is the numerators and this is denominator 1, 2 and 3. We don't have to go to 4, 5 like this because our configuration is D3. The value of R is 3. Number of electrons in the d orbitals is 3. So that is the limiting. So if we calculate, this is 120. So n, okay, simple, 10, 9, 8 divided by 1, 2, 3, 120. Let's take another example, and that is D2. Remember, right in the early lectures, I said that D2 contains 45 microstates. Now see how easy it is. The value of R is 2 in this case, and value of small n is equal to 10. So here is 10 divided by 1, okay, multiplied by 9 divided by 2. Okay, we do not go any further than that because our configuration is D2. So you calculate, it's 45. It is so easy. Find number of microstates. Another example of D8 now. Now D8 will be the same way. Okay, keep descending the maximum number, that is 10, down, okay, systematically, and keep ascending, okay, the denominator up to 8. Okay, so 10 divided by 1, okay, 9 divided by 2, 8 divided by 3, 7 divided by 4, 6 divided by 5, and like this till we come to 8, denominator 8. Okay, this 8 is because we have 8 electrons. If you calculate, it is 45. So see, the number of microstates in D2 system is 45 and in D8 system is also 45. I will make mention of it when I talk with you whole formalism. Okay, so next is how many microstates are present in F4. Now please note, this is F orbital. F orbital has maximum 14 electrons. Okay, so the value of n will be 14 now. Value of R is equal to 4 only. This. Okay, keep descending this down and keep ascending it beginning with 1 up to 4. So 14 divided by 1, 13 divided by 2, 12 divided by 3, and then 11 divided by 4. Okay, that's the maximum we go. And so if you calculate, this comes to so many. So it is so easy finding out any configuration. You compare how many microstates are there in F10. F10, okay, same way, n is 14, R is now 10. Okay, it is not, it was 4, F4, now it is 10, so this is 10. So n again the same way. Okay, numerator we keep on decreasing, okay, in descending order. Let it go in descending, and denominator, okay, ascend it till what? Now it is 10 here, so we will ascend it till 10. So 14 divided by 1, 13 divided by 2, 12 divided by like this, and last is 5 divided by 10. This 10 is because R value is equal to 10. If you do it, this also comes equal. So note, D2 has same number of microstates as D8. We have done it, 45. Similarly, F10 has same number of microstates as F4, 1001, and this is also 12001. So now we can go to a very easy topic, and that is whole formalism. Whole formalism. Okay, what is whole formalism? Okay, there must be something about wholes, and you will see, we will talk about that. Whole formalism states that for many electron system, more than one electron system, D2, D3, D4, something, one may consider system with E electron, for example D2, so that means E will be 2. Systems with E electrons of unpaired electrons equivalent to n minus 1. If it is, for example, D8, okay, so 10 minus 8 will be 2, that is D2. So D2 will be equivalent to D8. Similarly, P2, okay, is equivalent to, okay, 6 minus 4 is equal to 2. So P2 is equivalent into, now please note how we say that. This is P2 unpaired electrons, this is P4 configuration, and these are two unpaired, but then there are two holes I have shown here. So two holes are equivalent to two unpaired electrons. Now, please let me tell you, the spectra of P2 system will be similar to spectra of P4 system. That is why we do it. It is difficult to do it otherwise, but with the help of this whole formalism, we can predict what will be the spectra of, let us say, P2 and then of P4. Similarly, here is P1. So P1 will be equivalent to P5. Why? Okay, maximum number of electrons in P is 6. If you subtract 1, it is 5. So this is the configuration. So there is only one hole in it. So one electron equivalent to one hole. This is 4d4, and here is d4 should be equal to 6 plus 4 equal to 10 total number of electron wave. So again there are 1, 2, 3 and 4 holes in it. So this is equivalent. So please note F4 and F10, F10 and F4. F10 looks like this, and it has 4 holes. F4 has 4. So F4 is equivalent to F10. Briefly, Pn is equivalent to P6 minus n. Okay, Fn is equal to F14 minus, and Tn is equal to this. Now, the whole formula in this actually, I think, let me tell you that we will be learning about the spectra, UV visible spectra. How many bands are there in a D1 system? for example, it contains, let us say, 1. So then, okay, its equivalent D1, the equivalent will be D9. So D9 you will also see will have only one band. D2 has 3 bands. So D2 in whole formula is equivalent to D8. So D8 will also have 3 bands. So this is the importance of whole formalism.